Hello everyone and welcome to the another episode of Data Structures and Algorithms. So in this episode we are going to explore a data structure known as stack. We are already comfortable with a data structure known as arrays. We know that arrays are nothing but a collection of similar fundamental data structures like integer and integers as well as floats or characters. An array of character is known as string and rest of them are known as simple arrays. So this is how an array is represented in a memory of a computer. Now I want to give a bit more flair to this array. I want to use it for my own purpose. There is a nice data structure known as stack. So usually stack utilizes these arrays in order to operate. So I will show you actually how a stack looks like. So you must be aware of stack of coins or stack of plates. Basically, we are just using the concepts from real life to create data structures in the world of computer. So this is a simple stack and these are all the members of that particular stack. As you can see, one end of that stack is open and another end is closed. So we can insert and remove the elements only from one end. Okay, from this end only we can insert and from another end we can remove. And 1, 2, 3, 4, 5, 6, 7. The size of this stack is 7. I mean, there could be many types of stacks. So suppose if you are going to use arrays and your programming language doesn't allow arbitrary number of arrays, okay, or arbitrary length of arrays, then the size of your stack which you have implemented using those arrays is going to be fixed. But if your programming language allows you to add any number of elements to your arrays, then you are going to have a stack without any sort of fixed size. Or if you are going to create a stack using linked list, then you are not going to have a fixed size for your stack. So we are going to discuss that thing in the later part of this episode. But for now, just remember that this is nothing but the real life representation of a stack of coins or a stack of plates or a stack of books. You will always be able to take out anything from the top, or you will always be able to add something in the top. But if you try to add something in the middle, then it is going to be a bit difficult and you can't even take something out from the middle. Similarly, with the bottom also the same case is there. You can't add something or take out something from the bottom. So this is a stack, real life representation of stack in the computer memory. And this is a very useful data structure. Now I'm going to tell you what are the applications of stack and all. Okay, but before that we are going to understand how we can perform a lot of operations on stack. So there are probably 2 or 3 fundamental operations the way you see it. The first operation is you can check if the stack is empty, empty. So if there are no elements, then this stack is empty. And then you can push an element. Push means add the element from the top and you have to pass it the element to be pushed. You have to pass it a number or a character or something. And there is something known as pop. Okay. So this pop is something like you take that element out and it is going to return you a value and you can assign it to a variable var1. Okay. Push is going to put the element and pop is going to take that element out. Now suppose this is a stack and let me add the elements one by one. So let us say 0, then I add 6, then I add 3, then I add 4. Now I am going to pop the elements. Okay, so I have just pushed. So the first operation was push 0, then push 6, push 3 and push 4. And after I completed this sequence of operations, the stack became full because there are only 4 places in this stack. This is only sample stack. You can even make a bigger stack. Now I want to pop an element. Then the element will come in this order: 4, 3, 6 and 0. So this is the reverse order in which we have pushed the elements. So this is known as last in, first out, also known as LIFO. And this is very interesting feature of that stack. And stack is not actually very fundamental when it comes to programming world, but it is actually very, very fundamental when it comes to microprocessors. Now I will tell you how stack actually can be very useful in the real life. So I'm going to tell you the example how stacks are useful in real life. Okay. So now let us come to the programming. Suppose we have a routine, and in that routine we are call routine 2, and this routine internally it is calling, suppose this is the definition of routine 2 and it is calling routine 3, call routine 3. So now let me tell you how the flow of execution works. So this is a stack and our program counter is a place where we are storing the address of the current or the next instruction. Okay, this is known as PC, and this is the hardware stack, HW stack. So I am actually into routine 1 and I am executing all these statements. The control of your microprocessor or your compiler or your interpreter is executing everything, and we are actually here at call routine 2 statement. Then what is going to happen is that the address ADD1 is the address here, okay, and this address will go to the stack. So I will write here ADD1, and the program counter is going to switch to the place where it finds routine 2, and it is going to continue executing routine 2. Now we are in the call routine 3. Program counter will again, this is address, let's say 2. This address 2 will be added to the stack. Now routine 3 has finished execution. Okay, now the program counter wants to know what was the place from where to resume the execution. Now we have actually branched here from 2 points, add 1 and add 2. Okay, but the last point was add 2, and it is at the top of stack. So the control of your microcontroller or your interpreter in programming language is going to pop the stack, retrieve address 2, and from that address 2 it is going to continue execution. And when this routine 2 is done executing itself, it is actually again going to look for the address from which it actually made a jump, and that address can be found here at the bottom of stack. Again, pop statement will be executed at the hardware level, and program is going to resume the execution from address 1 where it left actually, and it is going to run all the instruction from that particular place. Okay, so this is a microprocessor instruction which I remember from my microprocessor classes, but this is the general concept of stack. So this is actually literally physical representation of stack. So in microprocessors, probably it is implemented at the level of hardware. Okay, in our programming languages, we just create models by writing codes and defining the operations on arrays and linked lists. But in the hardware, it is created at the level of microprocessor. And suppose if your microprocessor is a very advanced microprocessor, then it is going to have a set of stacks for all the cores. So suppose if you have got a 12 core microprocessor, then it is going to have 12 different stacks so that it can run 12 different processes simultaneously, and it can branch like this, and it can actually call all the subroutines, and then it is going to pop the items from the stack and go to the earlier addresses. So this is the very real life implementation of the stack. And let us see another simple example. I can't actually cover all the examples in a single episode, but I will tell you about the fundamentals of the stack and some sample examples how we can use them in real life. So suppose I have a string, let us say Ashwin, ASHWIN. Okay, so this is Ashwin, and I want to reverse a string. So I can either actually put it in a loop and do something, right? Or I can, better way, do it in a stack. So I'm going to define a stack in my program like this. This is a stack of, let us say, size 100. So I think nowadays we have got a plenty of memory, and let's say each character occupies 1 byte. Okay, it is a single byte character in that programming language model. Then the size of the stack is going to be 100 bytes. So this is a character stack of 100 bytes. Then what I'm going to do is I'm going to insert all the characters in my name to the stack one by one. So let us insert them. A, S, H, W, I, N. Okay, so we are executing this push statement 6 times. We are going to probably have a loop. Let's say for I equals to 0, I is less than 6, I plus plus. Okay, and we are pushing str1, that is the name of string, str1 equals to of I, and we are pushing it. Okay, so this is how we have pushed it. Now we are going to write another small piece of code saying for, again we will use the same thing, I equals to 0, I is less than 6, I plus plus, and I will say pop. Okay, so there will be another string known as rev. So here rev equals to empty string. I will just say rev equals to rev plus pop, and it is going to keep on adding the popped character to the particular string. It is going to concatenate for every iteration. And let us say in what sequence the characters are popped. It is N, I, W, H, S, A, which is nothing but rears of Ashwin string. So this is how we can use a stack to compute the reverse of a string. Another interesting example is palindrome, and it is very, very interesting. You will actually like this. You will love this. You will actually fall in the love with this data structure, because we know that palindromes can be written like this 101. So this is a binary palindrome number. So from both the ends, it is actually going to represent the same number. Now suppose if I want to say mom, which is what most of the Western people affectionately address their mothers. So in whatever direction we read this string of characters, it is going to read the same way. Okay, and now let us take a binary number. So binary number will have the positional values. So 1, 4, 1, 6, 1, 4, 1. In whatever way we compute the exact value of this number, it is going to be the same thing. It will actually give us the same value. So these are all the examples of palindrome numbers and palindrome strings and all. Basically, these are all palindrome strings because numbers can also be represented as strings. And anyway, even when we compute their value after computing it both the ways, it is going to be the same. So this is something known as the phenomena of palindrome. And we can actually use stack to check if something is palindrome. And that algorithm is also very simple. So here we have 101. Okay, so I just actually pushed all the 3 elements using the push operation. Now this push operation is completed. Now what I'm going to do, I'm going to write a for loop for I equals to 0, I is less than the 3, okay, because this is a 3-digit string, I plus plus. So here I am going to write my logic. I will say if pop of this stack equals to str of I, then result equals to true, and else result equals to false, and break that loop. And in the end, I am going to return result. So this is how we can use a stack to compute the palindrome. So first time we are actually visiting it in straight way, and second time also we are visiting it straight way, but we are just actually comparing the characters with popped characters. So whenever we are going to pop that stuff, it is going to create a reverse string, and we are then checking the position of characters popped if it is same as the position of characters that we are visiting directly. Okay, or you can actually write a routine that is going to compute the reverse of that, and then we can directly compare reverse, or we can even actually do it in single line of code. I can just say str of 1 equals to rev of str of 1. If it is equal to 1, then return true or return false. Okay, and this reverse is going to have this entire logic. Okay, that we are reversing that string using stack. So this is how we can work with stack. So these are two very good examples. We are using stacks, and there are a lot of advanced operations that we can perform with the help of stacks, and it is not actually possible to cover all these operations in the introduction video. So we are actually now going to write various programs using programming languages like C, C++, Java, JavaScript, Python, C# to demonstrate a lot of applications and all the operations on the stack. So be patient and subscribe to my YouTube channel in case you don't want to miss any one of those videos. And you will actually find a lot of very good videos on my channel. So go ahead and search all the videos. You will find a lot of programs that are utilizing stack, and I have actually even mentioned that in the title of that video, as well as the hashtag that program is using the data structure stack. So I hope that you have understood the concept of stacks, and my handwriting is not very good, and I'm actually using this pen tablet very first time, so it is actually getting some time for me to get acquainted with all this digital learning and teaching devices. So please forgive me if I have committed any mistake. Thanks a lot again for watching my video lecture, and I will see you next time. Hey guys, welcome to this episode. From this episode onwards, we are going to see how to work with stack data structure with Python programming language. So this is a brand new series which is going to have at least 20-25 videos about stack and its applications. So we are going to see now how stack can be represented with Python. So basically stack is a linear data structure which has got only one end. It means that the second end of the stack is closed. We can only insert or remove the item in the stack from the top end, and the bottom end is sealed. You can visualize stack is nothing but the computer world representation of the real world item, stack of coins or stack of plates. So suppose you have a stack of plates and the plates are made of porcelain, and you try to take out any plate from the middle of the stack is going to collapse and you are going to have a lot of loss of your precious porcelain plates. Similarly, you can consider a stack of coins. You can always add a coin to the stack of coin from the top, or you can remove a coin from the top of the stack, but you definitely cannot access the bottom or any middle element or any middle coin, because if you try to do that, it is going to make the stack collapse. The stack will collapse, correct? So this is how we can work with the real life stacks. Now we are going to represent the same stack in the world of programming and computer science. So we are going to have a linear data structure, and then we are going to write routines in such a way that we can only remove or add an item into the stack only from the one end. So this is the representation of the push functionality, which is nothing but adding an item to the stack. So we are taking an integer and pushing it to the stack. So here earlier the stack was empty, then we pushed 1, then we pushed 2, 3, 4, 5 and 6. So this way we can add an element to a stack. Similarly, we can remove the element from the stack. So here that operation is known as pop. So the pop function is like that. You can always remove the stuff from the top of the stack, and it is not allowed to remove the item from the bottom of the stack or from the middle or anywhere else. Only the top of the stack can be operated upon. You can either push or pop an item from the top of the stack. So now we are going to see how to create a stack with lists in Python. So lists in Python are built-in data structure for Python programming language, and there are multiple methods that can simulate the functionality of stack. So let us see how it can be done. So I'm going to say stack is an empty list like this. So this is an empty list, and we can use the append function of the stack to push an item. So I'm going to say 1, and similarly I will continue pushing the items as shown in the image here. Okay, so we have from 1 to 6 we have items. So I'm going to just say 1, 2, 3, 4, 5 and 6. So this way we have pushed 6 items to the stack, and if I execute this, it is actually going to complete those operations by running this cell. Now I can just print the stack, and this is the output. This is the stack from 1 to 6. Okay, and now I can even pop items from the stack. So pop is going to return the topmost item of the stack. Okay, so I can just go ahead and say print stack.pop, and if I execute this, it will actually start popping the items from the stack. I can actually re-execute the same cells, but we will not know in the end that how many times we have executed the pop operation. So whenever you are going to download this notebook, you should be clear that what operations we have executed and how many times we have executed those operations. In case you want to go ahead and access this notebook, you can check the description section of this episode down below, where we have mentioned downloadable URL of the notebook that I have uploaded on the GitHub repository. And let us pop one more time, and after that we can just print the number of items in the stack. So this is how we can simply create a simple stack with stack data structure in Python, and we can use the append and pop methods of the list data structure in Python programming language to simulate a simple stack. So this is a very simple way of simulating. We can even write our own custom data structures, and we are going to see that in the coming episodes in this entire series. So thanks a lot for watching this video lecture. Do let me know if you have any questions or queries in the comment section down below. Thanks a lot for watching this episode once again, and I will see you next time. Hello everyone, and welcome to this video lecture. In this episode, we are going to see how to use the dequeue module in the collections in the built-in library of Python in order to create a stack. This is the second episode of our stack series, and I recommend you to see the earlier episode as well as an unnumbered episode where I am explaining you all the stack related stuff. So let us get started. And here I'm going to mention it in comments using collections.dequue. So here we are going to use the collections.dequue. So from collections import dequue, and here we are going to say stack equals to dequeue. So we are going to create an object of the data type dequeue, and we are going to name it as stack, and we are going to use it as stack. Now there are two functions for this dequeue. One is append and another one is pop. So the same way we had created a stack earlier with simple lists, and I'm just going to copy that code and run that. Okay, so here we are appending, and I will just go ahead and print stack. Let me execute this, and it is going to print the stack. And see here the difference. It is actually showing us that it is a list whenever we are printing the stack, and here it is showing us that it is a dequeue. Similarly, we have the pop routine. So the routines append and pop, they are same for dequeue as well as simple lists. That is why we didn't have to modify the code at all, and we are getting the same results. The only thing is that whenever we are displaying that stack, it is actually showing that it is a basically dequeue, and we are using it as a stack for our convenience. So this way there are many data structures that can be used for stacks. Basically we are just using the built-in routines of those data structures to simulate the functionality of stack. We can even build our own stacks with object-oriented programming in Python, and we are going to see that in the coming episodes. Thanks a lot for watching this episode, and I will see you next time. Hello everyone, and welcome to yet another episode of Stack Programming with Python. In this episode, we are going to see how to use queue in order to create a stack in Python. So I will just say here, using queue to create stack. So there is a built-in module known as queue in Python. Okay. So I'm just going to say built-in from QUEUE import LIFO QUEUE. So here we are importing the LIFO queue, and then we are saying stack equals to LIFO QUEUE LIFO queue, and here let us say max size equals to 3. Now we are defining a stack, and we are also defining the max size of that particular stack, and the variable name is same, that is stack. Now let us print the queue size. So this is going to return the current size of the stack. So as of now it is 0. Now let us push the elements, and the routines for pushing the elements is put stack dot put 1, 2 and 3, 2, 3, and if I execute this, it is going to put that particular element in the stack. Now we can even check the queue size now, and we can also check if that stack is full. So this routine dot full, it returns true or false based on the size of that stack. So it is returning true. It means that the stack is full. Now we can pop the items, and popping items is very easy. I will just say stack dot get. So it is going to remove the item from the top, and it is going to return it to us 3, 2 and 1. Now again let us execute stack.full, stack.queueSize, and it is going to show us the size, and earlier execution is showing us that dot full is false. It means that it is not full, and there is something known as empty, which is exactly diametric opposite of full, EMPTY, and it is going to return true now. So the stack is empty, that's why it is returning us true. So here in this episode we have seen the implementation of stack using a built-in data structure known as queue in the Python standard library. So I hope that you have understood this episode and all the demonstration that I have shown and explained to you. Do let me know if you have any questions or queries in the comment section down below. If you want to find the code for this episode, you can check the description section again, where I have mentioned the link to the GitHub repository where I usually keep on uploading the code. So thanks a lot once again, and I will see you next time. Hello everyone, and welcome to this episode of Python programming and stacks. Till now we have seen how to use the built-in data structures to simulate stack, but now we are going to define our own stack, and then we are going to use it for pushing and popping the elements in and out. So I'm importing from sys import max size. So it is going to use the max size element for returning infinity, minus infinity to be very frank. So whenever the stack is empty, we are going to return minus infinite, for which we are going to use this max size related stuff. So let us see, actually, we can't explain it in words before we code. So let's execute it, and let us define a stack, create stack, and stack is an empty list. So basically we are using the built-in data structure list for defining the stack. Let's say return stack. Here we are returning the stack. Def is empty. Here we are checking if the stack is empty, and we have to pass that stack to this function. Return length of stack equals to 0. So this is going to return true or false based on the evaluation of this particular expression. Now def push stack item stack dot append item print item has been pushed to stack. We are just trying to include some custom message for the push operation. We are just using append operation of the list to push the item. We have already seen the usage of append operation in the very first episode of this entire series. The only thing is that we are writing a wrapper around all that functionality so that we can have nice sounding method names or function names for working with our data structure. So essentially this is the same program, whatever we have seen in the first episode of this series. Def pop. Now we are going to pop an item from the stack, and if here we are going to check if that is empty, is working properly, is empty of stack, then return str of minus max size minus 1. So here we are returning negative infinity minus 1. Okay. And yeah, it is cool. And finally, we are returning stack dot pop. That's it. So this is the first check. Otherwise, if we directly try to pop an item from an empty list, it is going to throw some Python error, which we really don't want. That is why we defined a custom function is empty, and it is going to return a Boolean value, true or false. Based on that, we can take further decision. Def peak stack if is empty stack and this peak function is basically going to show us the top of the stack. Now if it is empty, then return again that string of max size minus 1, the negative infinity minus 1, okay, minus infinity kind of stuff. Otherwise it is going to return stack length of stack minus 1. So that peep function is used to check the top element of the stack. That's it. It is very easy program. So I will just save this notebook and execute this cell, and let us see if there is any syntax error. So hopefully that there is no syntax error. And whenever we are going to write the driver program, which is what it is called, stack equals to create stack. And we are not passing any size or anything, though it is possible for us to write a code that is going to create a stack with limited length. Now let us say push stack and str of 10. Let me just copy and paste. So here I'm going to say 20 and 30. Let's execute this. 10 has been pushed to the stack, 20 has been pushed to the stack, and 30 has been pushed to the stack. Similarly, we can say pop and stack. Yeah, that's it. Pop stack. And let me run this. Again, let me run other stuff also. Let me run this one more time. And if we run this one more time, it should actually show us that minus infinite. So I'm actually very excited to see the minus infinite, how it is shown here. Okay, so this is the minus infinity stuff in Python. So we can actually write a simple code to check here itself that if it is minus infinity, then we will say that the stack is empty. So this is how we can simulate a stack with lists in Python. And this time we have written custom methods and functions to take care of all the operations. And we had actually simulated all the operations: push, pop, and peek. So these are three important operations. Peek means check the topmost element. I think that I haven't shown you the demo of peek. And we can actually see the demo of peek and say stack. I think that it is going to return us the minus infinite this time because the stack is empty. Let us push something in the stack. Let us run this code again and let us peek it. Yeah, 30 was the last item. That is why it is showing us 30, because it is at the top of the stack. So this is how we can simulate with lists and our own custom functions. Thanks a lot for watching this video. Do let me know if you have any questions or queries in the comment section down below, and I will meet you in the next episode. Hello everyone, and welcome to this episode of Programming Stacks with Python. In the earlier episodes, we have seen how to create stacks in various ways. Now in this episode also, we are going to see how to create stack, but we are going to use the data structure known as linked list for representing the stack, and that is very convenient because linked list can have any size. So theoretically, the size of our stack can be unlimited, except we have the limitation of the computer memory and processing power. We can't actually handle the stack with billions and zillions of items probably. Okay, so in case you want to make some smaller stacks like 1000, 10,000 items, this program is going to work very well. Now let us define a class known as node, and before that I'm going to have a comment: stacks as or linked lists as stacks. And I'm going to say markdown and execute this. Let us say class node def init self comma value. Self dot value equals to value. So this is usual thing for the node for the singly linked list. Okay, so actually the thing is that I will mention here it is going to use singly linked list as stacks. Okay, so self dot value, let me execute this. I forgot to execute it. Self dot next equals to none, and that is a simple node. Now I will run this again and let us create a class known as stack. So let us say def underscore underscore init underscore underscore self dot head equals to node, and it is going to read head, and self dot size equals to 0. So this is the initiation of the stack. Here we are creating a node and naming it as head and assigning it to the self.head of that particular stack. Now I'm going to say def str. So this is the function when we use the print function and pass the object of stack to that, it is going to print in the format of a string. So self, because this is a custom data type, we have to customize the print method for it. Cur, that is current, equals to self dot head dot next, and out is going to be a blank thing as of now, because we are then going to append data to the out thing. Okay, this out variable, it is going to be a string. I mean, it is a string. We have declared it as an empty string. While current, let us say out. Sorry, why am I printing C out? I guess I am missing C++ too much. And by the way, we are going to upload the same episodes in C++ also after a couple of weeks. So stay tuned to my YouTube channel and subscribe to my YouTube channel if you haven't done already so. So out plus str of cur dot value plus and cur equals to cur dot next return out colon -3. So this is going to return a string that is going to contain the concatenated representation of our stack as a singly linked list. So this is all about the print method, and it is actually going to return a string which print method will print. Now let us see the size. Def get size and self and I will say return self dot size. That's it. We are returning the size. Def is empty. Self return self dot size equals to 0, and here we are returning true or false based on the size of that particular stack. Now we are going to write the code for peek function. Def peek self, it is going to return us the top item. We have already seen this in the last episode, and we are defining it now here for this linked list. If self dot is empty is true, then raise exception. So we are using total object oriented stuff to write this. Raise exception. Let us say peeking from empty stack. And let us say return self dot head dot next dot value, and it is going to return us the topmost value. And finally def push self dot value, self comma value, sorry, and node equals to node value, node dot next equals to self dot head dot next, self dot head dot next equals to node, self dot size equals to self dot size plus 1. So this is how we can push the item to that stack. And let us write a simple routine for pop def pop self. Sorry, I made a spelling mistake again, so it is going to be a syntax error if I don't rectify it. I'm checking if that is thing empty. Self is empty. Then probably I'm going to raise an exception. I should actually raise an exception. So here we have the code for raising an exception. Popping from empty stack. And here I'm going to say remove equals to self dot head dot next, self dot head dot next equals to self dot head dot next, and self dot size equals to self dot size minus 1. And this is actually going to remove the element from that particular stack. And finally, we are going to return the removed value. Return remove dot value. So here we are storing that item in the temporary variable, and we are then returning that value because that return statement comes in the end. That's why we have to save it in the temporary variable. And here we are setting the pointer and here we are decreasing the size. That's it. And then we are going to write now the driver code. So let's go ahead and execute it and let us see if there is any syntax error. I think that there is some syntax error because let us see where it is. Okay. If it has to be if, not is. And if I execute it, there is no syntax error. Okay. And yeah, let's write the driver code. And since we are using object-oriented programming, I would like to experiment with if name equals to main stack equals to stack for I in range 1, 11 stack dot push of I. So I'm going to push the items from 1 to 10 into the stack, and finally I'm going to print that stack. Okay, let's say print and stack. We have already defined that str function above in the cell above here. So whenever we are going to pass that object to the print function, it is going to return the return of this str function. So that's how it works in the object-oriented programming. And finally, for I in range 1 to 6, remove, or I will just say print stack dot pop. That's it. Finally, print stack. And if I save it and if I execute it, it is going to show us this sort of result. Okay. So here we have pushed everything to the stack, and then we have popped everything from the stack. Not everything, we have stacked only 5 items, and this is how it looks. So I hope that you have understood how we can create stacks with the linked lists. And from the next episode onwards, we are going to see how we can work with the applications of the stacks, like reversing a number, reversing a string, checking the parentheses, as well as infix, prefix, and postfix and their interconversions. So apart from the lectures where I'm explaining you the programming part, I am also creating the lectures or the episodes where we are just understanding those concepts theoretically using my digital pen and paper. And I urge you to watch all these episodes and to subscribe to my YouTube channel for gaining more knowledge on programming in general. So thanks a lot for watching this video lecture. Do let me know if you have any questions, queries, or comments. Thanks a lot once again, and I will see you next time. Hello everyone, and in this episode we are going to see how to check for the balanced brackets with stack programming and Python. So we know that one of the major applications of stacks is in compiler and interpreter design, and we can check the balanced parenthesis of any expression using stacks, and that is quite easy. I'm going to write definition of a function like is balanced. So it is going to return true or false based on the computation with stack, and that is quite easy. We will just define a stack as an empty list, a custom stack for internal usage. Then we are going to read that expression for char in expr if character in opening normal bracket, opening curly bracket and opening square bracket. So if the character is in any one of these three things, then we have to push that thing to the stack. Stack dot append char and else. If not stack, it means if the stack is empty. If the current character is not opening bracket, then it must be a closing bracket. So the stack cannot be empty at this particular point, correct? So if the stack is empty, then return false. It means that the statement or the expression that we are passing is not balanced. Similarly, let us check the other condition. CURRENT character equals to stack dot pop. Now the current character is the popped value in the stack, and if the current underscore character equals to the normal opening bracket, then if the character that we are reading from the string is not the closing bracket, return false. And I'm going to copy this and paste it. Okay. And we are actually going to write this entire block for rest of the two cases like this. The curly bracket, this is opening curly bracket, and this is the closing curly bracket. And this is the opening square bracket, and this is the closing square bracket. Okay. So it is going to return false if it doesn't actually find a match for the popped value in the character that we are reading. So our logic is that we are going to push all these values and then we are going to pop them one by one. And if we don't find the matching brackets, then we are going to return false. And now finally, we are going to check if the stack is empty. Here we are going to check if stack. Now, if the stack has leftover items, then it means that there are few parentheses, closing parentheses that are missing. And I'm going to say return false, else return true. So let us go through the entire program once again. So this is the balanced expression method, and we are passing that expression to that, and we are defining a stack with 0 elements, an empty stack. Whenever we have any sort of opening brackets, we are pushing it to the stack. And finally, we are checking if that stack is not empty, and then we are returning false. Similarly, then we are popping all the items one by one. And then if we don't find the match for the popped opening brackets in the closing brackets, whatever we are reading from the string or expression, then we are returning false. And we are doing it for all the three cases. And finally, we are checking if the stack is empty or not. And at this point, if the stack is not empty, then there are few closing brackets that are missing, and we are returning false. And finally, we are returning true only in one case, when the stack is empty in the end. Now let's execute this and let us write some driver code. So expr equals to and so this is a sample expression, and let's copy this. Let's paste it here. Let me copy this and paste it here. Let's execute it. And this is balanced, that is why it is saying true. Let me delete one thing. And let's execute this one again and this one also, and it is returning us false. Similarly, if I say something like this, only one closing bracket but no opening bracket, and if I execute it, it should return false. And also if we do it in the reverse order, then also it should return false. Okay. This is also false. So this is how we can check the balanced parenthesis or balanced brackets in any mathematical or computer programming related expression. This is actually one of the important functions of your interpreter to check for the correctness of the syntax. You go to any programming language, and if it has got an IDE, the IDE is going to show that some bracket or parenthesis is missing. And if it has got the compiler, I mean, you can't actually write the code in IDE, and if you directly send that program to compiler or interpreter, it is also going to use the similar technique to check for the balanced parenthesis in any expression that we are going to feed to that compiler or interpreter. So this is one of the most important applications of stack. So I hope that you have understood the concept and you have understood the demonstration. Thanks a lot for watching this video. Do let me know if you have any questions, queries, or comments about this. Thanks a lot once again, and I will meet you in the next episode. Hello everyone. Welcome to this episode. In this episode, we are going to have a look at how we can use stacks to reverse the order of the digits in a decimal number. We have already discussed the logic in the earlier video where I am explaining you the logic with the paper and digital pen. In this video also, I am going to explain that logic to you very briefly while writing the code. So let us get started. So I'm going to write here reverse the order of digits in a decimal number. So we are going to input it a string, and it is going to assume that it is a decimal number. Let us go ahead and start programming. Stack equals to an empty stack or an empty list. Def, or let us go ahead and write it in the same cell so that we will have the code for the entire stack in the same cell. Push underscore digits, digits, number. So this push digits is the routine for pushing the number, to be very specific, the digits of that number to the stack. I will say while number is not equal to 0, then stack dot append. If that number is not 0, then append number modulus 10, and number equals to integer of number divided by 10. So here we are computing the modulus of that number and pushing it to the stack, and then we are computing the number again, which is equal to number divided by 10. So we are first of all we are computing the modulus after dividing 10, and whatever is the remainder we are pushing it to the stack, and finally we are dividing that number by 10. So it is an integer, right? It will actually give you an integer result. So suppose you have something like 102, and if you run that 102 through this particular line of code, then it is going to return you 10. Okay, because it is always going to return you an integer. The actual output of this number by 10 will be 10.2. Since we are converting it to an integer, it will only return the integer part. So this way we are dividing that number by 10 every time, and whatever is the modulus of that division or the remainder of that division, we are pushing it to the stack. Now let us see how we can reverse a number. So def reverse number let us say push underscore digits number. We are pushing the digits of that number here, and we are basically calling this push digit. Now let us say reverse. So in this number we are going to store the reversed number, and let us say I equals to 1. Now let us go ahead and start popping and processing this. While length of stack is greater than 0, reverse equals to reverse plus stack and length of stack. So this is the top item. Basically this is the functionality of peep function multiplied by I, and stack dot pop. Here we are using the pop operation, and we are popping that and not storing it anywhere because we have already used that peek functionality and multiplied it with 10 or multiplied it with I. So this I is going to tell us the positional value of that particular digit in the reverse number, and then we are adding it to the reverse. Basically earlier reverse was 0, and then we kept on adding it. Finally I equals to I multiplied by 10, and here we are going to say return reverse. So when this while loop finishes the execution, the reverse will have the value of the reversed digits of that decimal number, and it will be very interesting to see this in action. So I executed it, and there doesn't seem to be any sort of syntax or spelling related mistake or error. I will choose a number 1, 2, 3, 4, 5, simplest one, and reverse number, or directly we will pass this number to this function call, and let us see what is going to happen. And here we have the reversed thing. We can even check if a number is palindrome. I will say if, or let us say number equals to 1199911. So this is a palindrome number, and if number equals to reverse of number, print palindrome, else print not palindrome. And if I execute this, oh, it is saying that it is not palindrome. Yes, it is not palindrome. Sorry, I made a mistake. I forgot to type 1. So if I execute this now, it is saying palindrome. And if I just write something like this, 1, 2, 3, 4, 5, then it is going to return not palindrome. And we can actually put this entire stuff in another routine where we are checking for the palindrome or not. And that is how we can check if a number is palindrome using the stacks. So thanks a lot for watching this episode of Stack Programming with Python. Thanks a lot once again, and I will see you in the next episode. Hello everyone. Welcome to this episode of Stack Programming with Python. In this episode, we are going to see how to use a stack to reverse the individual words of a string. So before getting started, let us restart and clear the output because we are going to require the same notebook. And meanwhile, I will type in reverse the individual words of a string. And if I choose it as a markdown, it is going to make it a title. Now let us define our own stack as an empty list. We can even take a linked list, but then the operations will be a bit more complex and we really don't want to get into complexity as of now because our main goal is to reverse the individual words of a string. So I'll say def reverse words. And I'm passing a string to that. Basically, I'm assuming that the variable type is string because Python doesn't allow explicit declaration, not that I have seen. Okay, and stack equals to list. So, okay. So what I will do, I will delete this stack thing here from here, and here I'm going to have an empty list like this. Now I will say for I in range of length of string. So this is going to run until the last character in that string is read. Now if string of I is not a space, so this is for empty space. As long as the character that we are reading is not a space, then we continue appending the stack with that particular character, okay, that we are reading. Otherwise, I'm going to say else while length of stack is greater than 0. So here we are checking if that stack is not empty. And if it is not empty, then print the stack of -1, comma, end. So here we are just printing an empty string and stack dot pop. And we are popping the words from stack and we are printing again the empty string, okay. END. Now after the last word, so this way we are going to traverse the entire string. This is the logic of reversing the individual words. And let us actually check for the case where we are going to see the last word. So while length of stack is greater than 0, print stack of -1, comma, end, and finally stack dot pop. So this is the entire logic for reversing a word. Basically, we are reading all the characters until we encounter the space. We are putting all those characters in a stack, and as soon as we encounter the space, we are popping all the characters and printing them on the screen. And then we are checking for the special case where it is the last word in that entire string. Now let me execute this and see if there are any syntax or logical errors. Logical errors we won't understand unless we really call this, but syntax errors and spelling mistakes can be found out. So there is no syntax error or spelling mistake. Let us say reverse words Ashwin Pazankar. And if I execute this, yes, it is actually printing the reverse of that entire string and it is actually removing the space. And we can even say Python is the best. Python is the best. And let me execute this. And this is the output. And this is the output of printing Python is the best. And if I include a space here, then this thing will be in the end. So this is handling all the cases. Let us handle actually this case where that string is empty. Let us see what is going to happen. Okay. And let us provide us with spaces. This is single space and multiple spaces. So these are all the test cases. We are inputting various types of strings to our function that we have written to reverse a string, and we are entering various types of inputs to see if our functionality breaks. So this is something known as testing. I have spent a lot of time in my life working as a tester for various organizations. That is why I always write some small test cases for all of my programs, and I show you how to test your, or how to unit test to be specific, your programs that you have written in any programming language. So I hope that you have understood the concept and you have understood the demonstration that I have shown. In case you want to know the concept in more detail, check the earlier episode where I am explaining everything in detail using a whiteboard or paper and pen. Thanks a lot once again, and I will see you next time.